Hi everyone. So now let us digress ourselves and try to solve question from mathematics. This question can be useful for data science and AI, Fox, computer science for all the branches as well. And this question was basically asked in GATE 2019 in electronics and communication paper. So those who have finished my playlist on probability and statistics, and those who are having the knowledge about exponential distribution, so they will be able to solve this question, right? So let's directly dive into our favorite board. So as you can see here, the let capital Z be an exponential random variable with mean 1. So they have given the mean 1, right? But it is not going to affect your answer, right? That is the cumulative distribution function of G is given. So you know that whenever cumulative distribution function is given, so finding probability is very, very easy, right? See, if you have been given a density function, right, then finding probability can be little challenging for computer science folks and for other branch of engineering, those who are not good at integral, right? So during my lecture also, I always suggest that if cumulative distribution function is given, so you can directly find out the probability, right? You don't have to compute integral, okay? Whether this is continuous random variable or discrete random variable. But if density function is given for continuous random variable, and if you want to determine the probability, so probability is nothing but the kind of area, right? You have to compute the area, means you have to go for integral, right? You have to compute integration. So let's see this question. This question needs the knowledge about conditional probability as well, because you can see they have asked the conditional probability. Okay. So remember, this Z is nothing but the random variable, and the value that is taken by the random variable Z is X. So don't get confused about X here, right? So they have cleverly given X also, right? So Z is a random variable. This kind of notation I have discussed many times, and the value that this random variable takes is X, and they have given the kind of exponential random variable. So it has uh, you know uh, the CDF. Okay, they have mentioned the CDF, right? Okay, so you don't have to compute density function in order to find the probability. Okay, it is very easy question. So can we move ahead? Yes. So this question was for 2 mark. Okay, let me verify whether this was for 2 mark. No, this was for 1 mark only, right? Okay, in GATE 2019. So since they are asking this, okay, so we can write this as probability of Z greater than 2, given that probability Z greater than 1 is nothing but the probability of joint probability, you have to write, because this is a conditional probability. So joint probability can be written as Z greater than 2 comma Z greater than 1 upon the probability of Z greater than 1. Can we write like this? Yes. If we have been given a conditional probability, so conditional probability can be expressed as the ratio of the joint probability upon the marginal probability. You know all types of probabilities, right? Since you have attended my classes, live classes, okay? So Z greater than 2 and Z greater than 1. So what is common here? So you can say that probability of Z greater than 2 is common upon, Z greater than 1 falls within the range of Z greater than 2. You can see here, this is 1, this is 2, right? Okay, so Z greater than 2, you can take Z greater than 2, right? Fine. So this is going to be Z greater than 1. Now you can write this as 1 minus the probability of Z less than equal to 2 upon 1 minus the probability of Z less than 1. Okay, I think this is clear. Now you know the definition. What is the definition of cumulative distribution function? That is f of x is equal to, it is directly defined as the probability x less than small x. Okay, so you have been already given this distribution, okay, in the question, so you don't have to worry about that. You can directly put here 1 minus 1 minus, right? So 1 minus the value taken by the random variable Z is 2, so e raised to power minus 2 upon 1 minus 1 minus e raised to power minus 1. So you can say 1 gone. So it is nothing but e raised to power minus 2 upon e raised to power minus 1, which is 1 by e only. And what is 1 by e? you know that 1 by E is going to be 0.36. And this is going to be the answer for this question, 0.36. So if you have attended my class, so you should be able to solve this kind of question very easily. Okay, so I hope this makes sense. Okay, so please remember that whenever you have to compute the probability, so you can always go for distribution approach, that is find out the cumulative distribution function. Okay, and that will make your life much easier. But let's say density function is given, and if you're comfortable with integral, so you can directly compute probability by finding the area or area under density function or computing integral. Okay, the geometrical meaning of integration is area under something, right? So I hope this makes sense. So this question can be useful for GATE, data science and AI for all the branch of engineering. Thank you.